Hi everyone, I'm Jackson Henry, and I'm here today to present our work, Does Hand Size Matter? The Effect of Avatar Hand Size on Nonverbal Communication in Virtual Reality. In today's world, communication between people is moving increasingly online, whether this be video conferencing on Zoom, texting, using social media to communicate, or even virtual reality. With this shift in online communication, we have seen research being done in order to determine the viability of these forms of communication. And what we have seen is that VR has a higher level of co-presence in comparison to other forms of online communication due to the presence of virtual avatars cohabiting a virtual space. And these virtual avatars can differ greatly from the highly accurate metahumans you can see in this top image to the more stylized, less detailed, less realistic meta avatars that you can see in the bottom image. But one thing that these applications have in common is that they use a one-size-fits-all approach, where the user's motions are retargeted to the avatar rather than being an exact replication of the user's motions. So we have seen through previous work that finger motion is required for comprehension in nonverbal communication, as well as the fact that small alterations to finger motions can affect one's perception of the avatar. So this could be something such as delaying the hand motion of an avatar slightly in comparison to the rest of the body. We've also seen that when scaling a user's hands to be smaller on a screen, that the virtual hand illusion will tend to not be present, but it has also been shown that in an interaction-based task, these hand size modifications had no significant effect on performance. So while previous work has investigated hand motion for communication and has also looked at the effect of hand size on the virtual hand illusion and interaction performance, no previous work has studied how hand size could affect nonverbal communication in a two-party VR communication scenario. Because the previous work shows that even small alterations to the hand motions, which are required for a one-size-fits-all approach as it requires motion retargeted, because these motions have been shown to be perceivable by users, as well as the fact that the majority of the literature on hand size changes in VR is not focused on communication-based tasks, because of this gap in the previous work, we wanted to investigate if scaling of the user's hands would be perceivable in a communication-based task. To facilitate this, we designed a within-subject study with a total of 72 participants. There were 48 males, 21 female, and 3 non-binary participants. Each participant would first complete an embodiment phase. They would then begin the experiment with any of the 3 hand sizes, which can be seen here in the bottom image, with 25% smaller, fitted, and 25% larger respectively. These hand sizes were coordinated such that any point in the experiment, both participants would have the same hand size modification. And additionally, these hand sizes were counterbalanced throughout all of the trials. So once they had received their hand size, they would then complete 12 charade tasks, followed by a short questionnaire, all while in VR. And once this questionnaire was completed, they would then be given a new hand size, and they would start another charade phase. This process would continue 2 more times for a total of 3 trials. And after completing the experiment, they would be given a semi-structured interview to debrief, as well as get any closing thoughts on the experiment. So in order to focus our participants' experience on using their hands to communicate, we decided to use charades as our communication task. We chose charades as verbal communication could diminish results by being the driving factor for communication. So each participant's role was kept consistent throughout the experiment, with 1 performer and 1 guesser, and these participants shared a virtual environment but were separated in real life to avoid any unintentional communication. So the guesser's task for this experiment was quite obviously to guess the correct gesture the performer was gesturing. The guesser had a list of 3 options to choose from, which were hidden from the performer, and this list could contain any options from our 3 categories. So we had easy, medium, and hard. Easy would contain gestures that are just numbers, such as 1, 5, and 7. Medium would contain 3 distinct options, such as baseball, golf, and tennis, such that all of those gestures would be in a similar category. So in this aspect, it would be sports, but they all had very distinct movements between them. In our hard case would be a gesture that is similar to a secondary option in the list, such as kayaking, rowing, and swimming, where kayaking and rowing are very similar, but swimming is a distinct gesture from those 2. So once the guesser had pressed their respective button in relation to what the performer had gestured, They would then be prompted to answer how confident they were in that guess, from not very confident to very confident. And once they had selected their confidence, they would then be shown whether they got the previous guess correct or incorrect, and the next charade trial would begin. The performer's task for this experiment was also quite obviously performing the charades. They would be shown text above their partner indicating what they should gesture, and this text was hidden from the guesser to avoid any cheating. Additionally, as you can see here, the 3 options that were shown above the button for the guesser cannot be seen by the performer, and this was also to avoid any cheating. So once all 12 of the charade trials had been completed, the questionnaire phase would begin. The participants would be separated by a virtual divider to ensure there was no collaboration in the completion of the questionnaire. And this questionnaire consisted of 25 questions, with 1 extra for the performer pertaining to their perceived ease of gesturing. Some of the things that were measured on that questionnaire were overall user experience, with questions pertaining to ownership, agency, and workload. And we also measured their communication experience with questions pertaining to message understanding and communication satisfaction. Additionally, we have objective measures that measured their charade performance in the number of correct guesses, each individual question completion time, as well as the motion data for all the participants. So our hypotheses were that the fitted hand condition would receive higher ratings for the subjective measures in relation to user experience and communication experience in comparison to the altered hand sizes, as well as the fact that the fitted hand condition would result in faster completion times than the altered hand sizes. However, the results only showed a modest influence of hand size. We found no main effect on our objective measures relating to task performance, and we found only 1 main effect on our subjective measures, which was on temporal demand. But the post hoc was not significant and only indicated a trend that the smaller hands would lead to lower temporal demand than the larger hands. Additionally, only 32 of our 72 participants noticed the hand size change, which was determined through our previously mentioned semi-structured interview. This surprised us, as we believe the modifications to be significant enough that every participant would have noticed. But when focusing on the group of participants that did notice the hand size manipulation, we did find significant effects on hand size where both temporal and physical demand were lower for the smaller hand size rather than the larger hand size. We also saw some differences between the roles, which was expected. The motion data differed significantly, with the performer having much higher average hand velocity and hand translation. But we also found that the agency was significantly higher for the guesser in comparison to the performer. One reason for this result might be that the guesser interacted with the virtual buttons more than the performer did, but another explanation could be that the performer had more potential for tracking errors in comparison to the guesser, as the performer did move their hands more than the guesser did. So although we hypothesized that the fitted hands would be better for a communication task, we found that there is some tolerance for reasonable hand size differences in virtual environments where the main task is nonverbal communication. Therefore, in an entertaining communication task such as ours, a one-size-fits-all approach should be sufficient. But more work is still needed to determine if these modifications could affect a subgroup of participants. For example, experienced users versus inexperienced users could have differing results, as we found evidence that the more experienced users were more likely to notice the hand size modifications than our inexperienced users. So the main limitation of our work is our decision to use a robotic-like avatar for each user, which could explain our lack of significant results. We chose to use this avatar as we wanted to avoid any race or gender differences between the participant and the virtual avatar. So for future work, it may be interesting to investigate how different alterations to the hands may affect communication, as well as using a more realistic avatar or one that is matched to each user may make these alterations more noticeable. We would also like to see if these results would be different in other kinds of communication tasks that require both users collaborate rather than the mainly one-way communication that ended up occurring in our task. Please refer to our paper for any additional details. And if you have any questions, be sure to ask me at the social interaction and collaboration session where I will be presenting this paper. Thank you all for listening.